So, knowing these features, let's look at these examples. You should have done these in your notes already, but let's just revisit them for a moment. So look at this one, log base 2 of x minus 3. Now don't worry about that 2. The 2 is not changing your shape. But just like your other equations, whatever happens to your x, whatever added or subtracted, those will change it. So what's happening, what is that x minus 3 doing to our graph?
Right 3.
Just like before, it's opposite logic, so it's going to be right 3. It's going to move everything right 3. Anything else happening to transform this graph from just being a basic log of x? No, nothing else is going on. So I'm moving it right 3. So go back to your parent function. This is what I mean by the parent function right here. Start with the asymptote. This asymptote's vertical. If I move my graph left and right, will it move? Does it because it has to stay attached to this thing. So if I have to move this left or right, that asymptote has to move with, right? You with me? And we said it's going to move right 3. So I'm going to move it right 3. 1, 2, 3. Asymptote has moved now, where x is now 3. That point, that was 0, 1. Well, if it's moving right 3, that means I'm adding 3 to my x component. I'm not moving up or down, so I don't have to add anything to the y. So now my point would be at 4, 0. Shape is the same. Just draw it in. Is that okay? So my 4, 0 is that point. Now, when you do this, you're going to have to tell me domain and vertical asymptote. So we did vertical asymptote first thing, right? We said that that is x is equal to 3. Remember, an asymptote means that the line of the graph is going to approach it, but never actually cross it. So when you do domain, whatever number you have here is going to be the beginning of your domain. And then it goes on to positive infinity, right? Yes. So we'd have to put a parenthesis with the 3 because it's never going to actually touch it. But it does connect to the asymptote. So notice this little pattern right here. Whatever the asymptote is will be the beginning of your domain. Or one of the endpoints at least. All right? So let's try the next one. Look at this one. 1 minus the log base 5 of x. What's happening here? How's it changing?
Up 1, but...
Yep. Up 1, because that 1 is really a plus 1, right? It's going to move everything up 1. What's the minus going to do? Which way? Reflect over which axis?
X.
X. How do I know? Okay, if it's y, then it would just be happening to that little x right there. And that doesn't happen very often. It's like it would be in parentheses and it would be minus x. All right? So it's moving up 1, reflecting over x. So go back to the parent right here. No, it's not going to move with, is it? All right, so vertical asymptote. If I move that point, if I move this point up and down, is it going to move my asymptote? It's going to stay put. That's going to stay put. So my asymptote will be right where it started at x equals 0. But that point, that was 0, 1. Okay, we're not moving anything left and right, but we are going up 1, aren't we? So my x is going to stay 1. My y is now 1. So my point has shifted just slightly. So let's come back over here. Vertical asymptote we said was x equals 0. So my domain would then be, where is it approaching? 0. Parenthesis, because the asymptote means it's going to be parenthesis. And the asymptote's a 0, and it's going to go to positive infinity. Again, notice this pattern here, 0 and 0, right? That's the beginning of your asymptote. Oh, I didn't reflect it, did I? Row. My bad. Let's fix that. So if I reflect over x, it would look like it would go this direction, right? If I flip it that way. Sorry, I missed that. Okay. Last one, look at this one. What is going on here? What is the 4 doing? It's going to move everything up, up 4, and the x plus 1? Left 1. Okay. So will my asymptote be moving?
Yeah.
Yes, it's going to move wherever x moves, right? So it's going to move left 1, so it's now going to be over here at -1. And my point that it was 1, 0 is going to be going up 4 and left 1. So now that pointer will be at 0 and 4. So, looking like that. So when you graph these for me without your calculator, these are the kinds of things I'm looking for. I'm looking for where's your new point going to be? Where's your asymptote? So if my asymptote's at -1, then my domain would be -1 to positive infinity with parentheses, right? Yeah? You will have to graph these without a calculator, so don't be super reliant on the calculator. Yes, it's a way you can learn, but don't make it your only way. All right, find those patterns that help you get there. Eventually, I will be showing you how to find those x-intercepts. You know, this one is already the x-intercept. It's already done because it happened to land on the x-axis.
Calculator, is there a button?
No, we're going to solve it. Going to use your brain and do the math, Nixon. All right, we will be getting there, and that's something we'll do after we come after the break. So today your goal is to be able to graph these guys just as detailed as this. That's all I'm asking. Not 100 points perfect, just a few points just right on. Asymptotes labeled, all the things. First 12 questions of the practice is what you're going for. Not